So yesterday we just briefly discussed about Spark components. Okay, the Spark components such as what is the basic component here? Spark core, which uses the DAG engine, which is responsible of entire RDD flow execution. On top of this Spark core, different components again, like a Spark SQL. So it is providing you two contexts. One is SQL context, and second thing is Hive context. Using SQL context, you can apply SQL statements over RDDs. Okay, and there is a special process. What is that process to apply the SQLs on the RDDs? We'll see in later. So first we need to create RDDs. Later we need to provide schema for that. Then we will convert them into data frames. Data frames will be registered as tables on such a way some process is there. So this process in the technical part we will discuss. And second context is Hive context. Using this Hive context, you can directly interact with the Hive data warehouse, because Hive is data warehouse environment in our Hadoop. So instead of executing your Hive queries from the Hive, if you execute Hive queries from the Hive, that will be converted into MapReduce, but we don't want MapReduce. We want Spark's in-memory computing models. That's why we are integrating our Spark with Hive by using Hive context. And next one is a Spark mlib. Is a library for machine learning. Machine learning is an approach, okay, how to train our application. That means applications will learn. That means the models will learn from data patterns. So for this, like different algorithms will be there, like supervised, unsupervised, reinforcement, and semi-supervised. In this way, different approaches will be there. So for all these supervised, unsupervised, for all these related algorithms, that means predefined models are available in this library, so that you can develop powerful predictive applications by using Spark. And third thing is Spark GraphX. This is what like a graph data. So Spark GraphX simply like the purpose of Spark GraphX is graph data processing. Example for this graph data processing is the logistics department, or else you can say even Facebook user and friends connections, such kind of things. Okay, and that means record to different connections will be there. For example, A is one user, A has a friend B, again B is user, B has a friend C. Of course there is a relationship between like A to B and B to C, but there is indirect relationship between A and C also. So such kind of data is called graph data. To process and to analyze graph kind of structures, Spark GraphX is one of the ecosystem. So it's not, we cannot say it as an ecosystem like Hadoop. This is just one of the component in Spark. And third thing is Spark streaming, which is used for the microbatching. What exactly the microbatching? Today we will continue the discussion about this Spark streaming. Is microbatch. So what exactly this microbatch? What is streaming? What is microbatch? And all these things. Now we will continue the discussion. So, but all the secondary four components will run on top of this Spark core. Again, this Spark core is interacting with any cluster. The cluster can be Hadoop, or cluster can be even Mesos or AWS. Okay, that means once again I will repeat that statement. The Spark can run on the following systems like this. Basically with Hadoop and even with Mesos and AWS. That means the Spark independently cannot be executed. It needs one cluster support. The cluster can be Hadoop, Mesos, AWS. So based on this, you can say like a Spark is not at all replacement for Hadoop. Spark is replacement for only for MapReduce only. Okay. So you can write high level diagram like this. Let's say it has a Spark core engine. So here you can use Hadoop, or even you can use Mesos. And even the storage platform can be even cloud, that is AWS. It can be of anything. On top of this Spark core, different components. One is Spark SQL basic thing is. Second thing is Spark MLlib, which is machine learning. And Spark GraphX, which is used for the graph data processing. And most important thing here, Spark streaming. Okay. Once you have understood all these things, later you know how to integrate, how to establish the communication between different components like MLlib and GraphX, the interaction between GraphX and the streaming. Again, streaming and MLlib, later we will understand. So first of all, now my concentration today, we will discuss about this Spark streaming. So before going into that one, let me take a simple overview about different types of big data applications. Okay. Types of big data applications. If you look at this diagram, you will understand the things. See, generally you can classify the things into three types. One is online applications. You can say these online applications as like real-time applications. That means on live, end users will be interacting with the applications. User interactive applications are called online. And second thing, you can say microbatching. Nowadays especially, there is a great importance for this microbatching. You can say mini batch or small batches. Mini or small batches. This is just a normal traditional word. Official word is microbatching. And third kind of thing is batch applications. What you do regularly with Hadoop is that comes under batch applications. The Spark purpose is to perform the batches in the Hadoop environment or AWS environment. That is what like Spark purpose. That means here you will be using like Hadoop and previously MapReduce, now the Spark combination. Microbatching here, who is involving is Spark streaming will be involved. Then what is the general streaming applications and what is Spark streaming application, we will discuss now. To understand this, again I am coming to the online applications here. That means I am writing the picture like this, big data. The first one is online. This is micro batch. And final, the third one is batch. The place of Hadoop is batch only here. If it is online, you can classify this into two ways. One is transactional. See, if it is transactional, that means end user transactions. Previously, end user transactions will be directed to RDBMS. Because if you suppose small example, if you do ATM. That means like if you withdraw money from the ATM, that is one transaction is created. The transaction will be recorded into RDBMS. Pardon? Any question, please? Yeah. So all of you feel free to ask me, okay, to ask the questions, not a problem. Okay. So even if you have any doubt, if you share the question, okay, that's all the answer will be useful for all the people of this room. Okay, don't feel shy, and if any questions, all of you please ask me. Yeah. So if it is transactional, end user transaction, some simply end user operations you can say. So previously end user transactions will be recorded into RDBMS like Oracle, DB2, SQL Server like this. But what's the problem with this one is, in a particular moment, suppose 1 lakh transactions are happening, then RDBMS is okay, is able to tackle this. But think that now this is the area, in 1 minute or in this particular moment, trillions of transactions are attacking the server. Trillions of transactions are attacking the server. In such moment, for such kind of things, RDBMS would not able to bear it. Now we need high capacity transactional servers. These things are NoSQL databases. Here NoSQL databases means not only SQL. The examples for this NoSQL databases is MongoDB, Cassandra, such kind of things, Neo4j. All these are, even HBase also, in our Hadoop we use HBase, right? HBase also comes under this NoSQL, Neo4j. All these are the different examples. But what is the purpose of this MongoDB, Cassandra, Neo4j? This discussion later, because our topic will be diverted again. So when time comes to discuss about the NoSQL, we will have a discussion about what are all the different varieties of NoSQLs, purpose of each variety we discuss there. And also second category of this online is streaming, simply you can say. That means as user is performing different operations over the applications, without user knowledge, a lot of data will be logged. These logs comes under streaming. Or else if I fix a camera in your room, what that camera is doing, suppose some CC cam. That CC cam is keep collecting the pictures and writing into some file. So that is also streaming. And best example, suppose we are chatting, you and me are chatting. Suppose in this moment only 2 messages. Okay. If still the chatting continues for long time, the messages keep increasing. All these are the different all these things are comes under streaming area. So simply here, what is streaming data means? The data which keeps generating the logs or chatter files or even transactions also, because in this moment, even though if I stop the transaction, some other user will be connecting from some other place and he is doing transactions. Everything is comes under streaming only. Okay. So to capture the high speed rate of streams, we have different systems here. That is a Flume, Kafka, Storm, okay, and Spark streaming, and even Trident. Such things, all these things, purpose is to capture the streams. Okay, but here one is not a replacement to another one. Suppose there is a Flume, the Storm is not replacement to the Storm. Sorry, this Flume is not replacement to this Storm, or Storm is not replacement to this Flume. The Flume purpose different, the Storm purpose different. Like this, again there is a new component in our Spark streaming, and I don't misunderstand that Spark streaming is not replacement to the previous streaming technologies. The purpose of Spark streaming is clear, that is microbatching. So Spark streaming place is this one. So now briefly I will explain what is the purpose of each and every one. Then where Spark streaming will come into the picture, then where Hadoop will come into the picture. Let's understand this. Example for this batch is Hadoop. Okay. Now I am coming to one by one the Flume. Let's talk about the Flume. It's a stream capture system, you can say, and it dumps data into given target. So here stream capture system means it capturing the streaming data. They keep reading the streaming data and then it is writing into the given target. The target can be here Hadoop. Suppose I want to write the output into non-Hadoop applications. Directly it is not allowing me. That's why you can use JMS. But JMS is not distributed. For this the advanced is Kafka. Kafka is a brokerage system. In Kafka there are a lot of advantages are there. Like Flume, it can capture the streams. Directly applications can write into Kafka topics. Okay. Directly applications itself are able to write into Kafka topics. Even though thousands of source applications are writing the messages, Kafka can capture them. Kafka has that ability. Okay. And in the Spark streaming, I will give you a overview about a brief about even Kafka. One special session I will take on Kafka architecture. There you will understand. Even though like trillions of transactions are attacking, that means trillions of the transactions are are producing. Applications are writing trillions of transactions. All these things can be captured by Kafka, and it can make available of these messages to hundreds of or thousands of different target applications at a time. So that means simply Kafka is acting as a brokerage system between different applications. Suppose a .NET application is there, some Java application is there. .NET application wants to write something into Kafka, and Java application wants to read the same message from the Kafka. So if you are writing, you have to use producers. If you are reading, you have to use consumers here. This is like a publish and subscribe model. Whatever the applications wants to write into Kafka, they will publish. What are all the applications, different applications wants to read data from the Kafka, they will subscribe in terms of producers and consumers. So that once the data is kept into the Kafka, any other application can take it. It can be Hadoop application, it can be non-Hadoop application even Python application or Java application, .NET application or any other application can take those messages. Okay, this is what this one. That too, Kafka is offering you 100% message delivery guarantee. Even though in that particular moment, target application is busy, okay, still the message is available in Kafka topic only. When our target application is up, that means got free, it will come to the Kafka and it will take that message. So that 100% delivery guarantee it is offering you. Even though trillions of transactions are attacking Kafka, Kafka is capable of handling them. That means high load of transactions, it will handle it. Okay, that's why there is a great importance for Kafka. Nowadays, Spark with the Kafka integration, that is very much demanded in the industry. Okay, but what this Kafka cannot do? Suppose I have different applications. Different applications. These different applications are able to directly can write into Kafka. At the same time, a lot of streaming data is there. Best example, logs and tweets of social media or our charts, whatever it may be. These things will also can be directly written into this Kafka. Then who is capturing this one is the Flume is capturing, and Flume is writing into Kafka. Again here Flume and Kafka integration is required. And think that this is like a credit card applications. Different users are performing their transactions. These transactions fastly can be captured by this Kafka. But in this context, without Kafka, this capturing can also be done by this Flume. By using like your applications are embedding Flume API, directly applications are able to write into Flume also. But there is a problem with the Flume. Why we are integrating Kafka is, there is a problem with the Flume. The Flume cannot give you 100% delivery guarantee, point number one. Suppose if it is a log message, one of the log message missed, not a problem. By having the remaining log messages, I can analyze my data. Suppose today I am interested about like what is the people sentiment on the ban of 500 notes and 1000 rupees notes. I am interested into this one. So for this the required input, and the required input is available in social media, because different people use to tweet about this 500 notes ban or 1000 rupees notes ban. Suppose I am connecting with Facebook or Twitter or LinkedIn like this, and I am capturing the messages. In this moment, actually 1000 messages generated from social media, but at the time of receiving, some of the messages were missed. Some 4 or 5 messages missed. It's not a problem. By using remaining messages, I can analyze the sentiment of the users. Okay, in such case only we can use this Flume. That means if data is not sensitive, if data is not commercial, then you can use Flume in that case. See here in our example, the Flume is capturing data from logs, tweets, charts. In that case, I can engage Flume. Okay, because these are not commercial data. But the thing is, credit card transaction or any financial transaction, if even one single record is also very important, the record should not be missed, the message should not be missed. Safely the transaction has to reach my target system. That's why such kind of data capturing, the sensitive data capturing, I cannot give that responsibility to the Flume, because Flume cannot give me delivery guarantee. This is the reason number one. Okay, why I am not directing credit card transaction to the Flume. And second reason, in this moment, if the applications are few, like 10 different applications or 10 different sources or 100 different sources, not a problem. But the transactional frequency is very high. Suppose in this moment, how many people are doing credit card transaction entire worldwide? For example, let's consider one international bank called HSBC. For the HSBC, like in this moment, how many people are connecting in entire worldwide? Okay. Even though I am not doing transaction, you are not doing transactions in this moment from different parts of the places, even trillions of people are doing that swipes, that means transactions. Then there should be very powerful system who can immediately capture all those things without any delay. So such kind of load the Flume cannot tolerate. Okay. So where Kafka is having multiple brokers. Each broker is acting as a server. That means multi-server architecture. Generally, our entire Hadoop is one server. That means one cluster. Where Kafka is a each node is acting as a master. That's why multiple masters will be engaging. Okay, so that a heavy workload can be tackled by this Kafka. Very heavy, powerful, distributed messaging system the Kafka is. So that's why, like, because of these two reasons, the credit card transactions I am redirecting into the Kafka. But now here, I'm going to explain you what Kafka cannot do, what is the problem with the Kafka, okay, what Kafka cannot do, then what is the solution for this. Let's talk about this one. And suppose the transactions are happening now, but still, even though bank is having powerful like security systems and all these things, the credit card fraud transactions are happening. Now I want to detect, I need to capture the transaction, point number one. Immediately I need to detect whether it is a fraud transaction or genuine transaction. This is what our task. So for this, like, okay, this is completely the data science responsibility. The data scientist will give you a perfect algorithm. The Spark developer has to use that algorithm in the Spark mlib or some other thing. That is later next question. Think that there is some algorithm to detect the pattern of the fraud transaction. If the transaction matches to the pattern of the fraud transaction, then okay, we need to discard the transaction. This is what the expected solution. Now in this case, where Kafka is good is, Kafka is able to capture the streams. Even trillions of transactions are happening, is able to capture. And at the same time, even though thousands or lakhs of transactions are requesting, Kafka is able to supply. In that area only, Kafka is very strong. But capturing and executing the algorithm of the fraud detection, in such kind of cases, Kafka is very weak. A little transformations Kafka can do, but not the complex transformations. Because credit card fraud detection algorithm is not a simple algorithm, is very a complex algorithm. Such kind of things cannot be bared by Kafka. But in this context, who is strong? Whenever I got a record, who will decide, who will execute the algorithm, who will decide whether this transaction is a genuine or fraud? In that area, Storm is STORM. The Storm is very great system. But where Storm is weak, Storm cannot capture the streams, capture the transactions like Kafka speed. Even hundreds of transactions are happening, okay, Storm is good. Okay, if trillions of transactions are happening, the Storm is weak in that area. It cannot capture all the things immediately. Okay, but in that area, Kafka is strong. Now observe, Kafka has one plus point and one minus point. Storm is having one plus point and one minus point. What is the plus point of the Kafka? Fast stream captures. Okay, and where Kafka is weak in executing the algorithm runtime. He is weak in executing the given algorithm in runtime. In that area, Kafka is weak. Come to the Storm. Where Storm is strong, executing the algorithm on live, this is very strong. Whenever you perform a transaction, immediately the Storm will recognize it. Okay, whether it is a fraud or genuine, because based on the given algorithm into that Storm. But where Storm is weak, wherever Kafka is strong, in that area, Storm is weak. That's why we cannot expect all the features by the Kafka, all the features by the Storm. Let's integrate these two systems. See, now just observe, here I am engaging a Storm. What it will do? It runs pattern matching algorithm for to detect whether transaction is genuine or fraud. That means you can use this Storm for live analytics, real-time analytics, you can say. This Kafka, what it is doing? Capturing the credit transactions. That too not 100 or tens. Trillions of transactions are happening at a time. It is capturing. And this is weak for this live analytics. Storm is weak for to capture the trillions of transactions. That's why we are integrating these two. Kafka is capturing, from the Kafka the Storm is taking. The Storm will decide whether the transaction is genuine or not. Okay, now a transaction number 1 has been captured. The transaction 1 is passed to the Storm. The Storm will decide this is a fraud transaction. Okay, and rewriting the results into this Kafka. Because if it writes the transformed data to the Kafka, what Kafka can make available of these messages to hundreds of different other applications, right? Not only Hadoop is the target, a lot of other applications require the same data. So Kafka is able to make available of these results to other different applications. That's why again here Storm is rewriting this one into this one. And later come to this one. From this Kafka, here I am keeping Spark streaming. Here what I perform is, for every 5 minutes how many fraud attempts are happening from different places. Okay, such results will be such kind of area is called microbatching. See, entire day what happened? In entire day from Hyderabad, how many frauds, how many genuine? In entire day from Delhi, how many frauds are happening, how many genuine transactions are happening? Chasing such kind of activity is called batch. Your Hadoop is able to do that one. But for every 5 minutes, for every 1 minute, even nowadays the micro batching requirement came to seconds. For every 3 seconds, what is happening? For every 4 seconds, what is happening? In that area, we are interested. So such kind of activity is called streaming, Spark streaming. That means what Spark streaming is doing is keep collecting from the source and buffering them. Suppose here I fixed 5 minutes. Within the 5 minutes, suppose if there are 100 transactions or 1000 transactions, these things it will buffer. On that 5 minutes worth of data, it will apply your batch process. For every 5 minutes, one batch process, one separate batch reports, you will get it. So such kind of tasks are called micro batching. That means if I remove this Kafka here, directly, if I direct these credit card transactions to this Spark streaming, what the two activities will be missing? One, fast streams the Spark streaming cannot capture. Okay, because thousands of applications are attacking. The Spark streaming could not able to capture them like Kafka. And second thing is Spark streaming cannot analyze a record, a single record. That means single transaction as a fraud or genuine. That means Spark streaming is not fit for the live analytics. The Spark streaming purpose is micro analytics. This thing you can say near real time. Near real time. See, the Storm real time analytics, that means live analytics. The Spark streaming is near real time. For every 5 minutes or for every 5 seconds, what is happening, how many frauds are happening, such kind of things. Okay, later, each and every message to maintain the history, I need into Hadoop. Transaction as easily I want in Hadoop, that's why I'm taking all the things from the Kafka. At the same time, whatever the Spark streaming has processed the micro batch, the 5 minutes report, these reports also I'm directly writing into this one. This is transactions, this is micro batch results. Everything will be finally kept into this Hadoop. Now just observe, I am giving you some numbering here. This is number 1, this is number 2, this is number 3, and this is 4, this is 5, 6, 7, 8. Now try to understand each and everything. What is number 1 is doing? The number 1. Directly, the applications are writing into Kafka topics. So here, why Kafka? Question 1. Okay. Hundreds of thousands of different sources are writing. Kafka is able to capture them. Even the transaction count is trillions. A very attractive point in Kafka. And second attractive point in Kafka is able to make available of these messages to different applications. Observe in this context, Kafka is making available of these messages to Storm, is making available of these messages to Spark streaming, and making available to even Hadoop also. Or tomorrow you want to give SAP HANA. SAP HANA also can take it from Kafka. Or tomorrow some other Java application or web application wants to take these things. They can also take these things. That is what Kafka advantage. And also Kafka will ensure you, will promise you no message will be missed. That means giving you guarantee of message delivery. Because of these reasons, I am directing the transactional messages to Kafka. But at the same time, keep lot of logs, tweets, charts will be generating in our organization using Flume, because already in my existed application Flume is there. I will hand over only these kind of non-sensitive, that means non-commercial data, I will hand over to the Flume. Flume will capture them and again rewriting into Kafka because of further use. Later, what Kafka can do here? Come to the number 3. What is the problem of this Kafka? The problem with this Kafka is, here I am going to mark it as a problem. The third problem, the Kafka problem is, it captures the record but cannot analyze whether the record is a fraud or genuine. Suppose I am asking you one small IoT based application. Observe this. There is a meeting hall. Okay, in the meeting hall, in the entrance gate, suppose some camera is fixed. So whoever enter into the room, that will be captured into the camera, right? That means your CC cam, right? What is the expected operation is, whoever entered, that means that video streams have to be keep captured by this Kafka. Kafka is able to capture that one. And second thing is, what I want is whether the entered guy is a male or female, I want to find out. Understand? Here, what is the role of Kafka? Kafka is able to capture the video frame, but cannot understand whether the entered person is a male or female. It cannot understand. The Kafka cannot understand. Who is best capable of detecting whether the object is like a human or non-human? If it is human, whether it is a male or female, who is well capable of that one? The Storm is well capable of that one. That means on live is able to analyze each and every record. That means each and every transaction. In that area, the Storm is strong. Okay, now convert this example into the credit card. Credit card transaction captured by Kafka but cannot be analyzed genuine or not. That is done by Storm. Again, Storm has performed this. Storm has recorded this, whether it is a fraud transaction or genuine transaction. Later that report, it is again rewriting into Kafka so that other applications can take it. But where I am interested is, for every 5 minutes or for every 1 minute, how many fraud attempts are happening from Hyderabad, from Delhi, on that city-wise separate report I need it for every 1 minute. Okay. So in such case, the Spark streaming is well capable of that one. Again, the Spark streaming, whatever Kafka can do, it cannot do. Whatever Storm can do, it cannot do. But whatever Spark streaming is doing, these things cannot be done by Kafka and Storm. That's why there is a equal role of all these systems. There is a role of Kafka, there is a role of Storm, there is a role of Spark streaming. Understand? So based on this, you can commit for one understanding, the Spark streaming is not at all replacement for the previous streaming systems. Okay. Later, once Spark streaming has performed its mini batch reports, these reports you can write. If you want to write into Hadoop, you can write it, or else if you want to write into AWS, you can write into AWS. Okay, now our system is Hadoop. That's why the microbatching results we are rewriting into this Hadoop. At the same time, our Hadoop system has to maintain transactional history of all the things, but all these things are available in Kafka. From the Kafka, we are capturing all these things and dumping into your Hadoop. Understand? Again, here different batches will be running. These batch reports, again you can resend it to Kafka, the batch reports. If these reports are resend to the Kafka, from the Kafka, again other different applications can use these results. Whatever the results you have processed from Hadoop, if you rewrite these results into the Kafka, other different applications can use the results of the Hadoop. Okay, this is what like a full-fledged big data application. Now, in the beginning, our misconception is Hadoop is like a problem of big data, like big data is a problem, Hadoop is a solution. On that way, some wrong interpretation. Now, big data and Hadoop are not equal. In the big data industry, Hadoop is just one of the solution. And when that is like a full-fledged big data application is, if you take this NoSQL data, even here in this example, I did not consider NoSQLs, even NoSQLs also, the transactionals, okay, streamers, and all these things. If you integrate all this entire screen, that is what big data application. Okay. Now, all of you clear about this statement? And Spark streaming, the Flume versus Kafka versus Storm versus Spark streaming versus Hadoop. To capture streaming data, to capture the streamed messages, Storm to perform live analytics. This is to perform microbatching. This is to perform batching. See, nowadays especially sir, nowadays there is a great role of Spark streaming. Why? Because if you go back to 5 years back, 5 to 8 years back, microbatch means weekly once sir. Sorry, 10 years back microbatch means weekly once. 5 years back microbatch means one day once, daily once. But nowadays every minute is required, every second is required. A small example for this. Hello? Here suddenly my system got down. Yeah. Just like a small, very close example. You are interested in IPL cricket betting. Where you are interested, sir? If it is IPL betting, I think you are one of the member involved who greatly involved into this betting, sir. Today match by 9 it started. Think that up to by 3 the match is going to be finished. 9 a.m. to 3 p.m. It can be like 20-20 or 50-50 match. Okay. Let's talk about batch. What is the example of batch in IPL point of view? By morning 9, suppose as an end user point of view, as a results user of the batches, okay, point of view, just think it. There are two types of news users here. Suppose you came to office by 9 and by evening 5 your office is completed. After that relaxedly you go to the home and then you switch on your TV and you are observing like what is happening today for the IPL match. This is what a batch. But think that you are already greatly involved into the betting where you are interested. For every 1 minute what is happening you are interested. For every 1 minute you are interested about what is happening. Okay, every 1 minute, like every 2 minutes you will open your mobile and you will check the results. This is what micro batching. Okay, that to do. And one more very close example for the micro batching. I want predictions for next 5 minutes of shares. For every 5 minutes I want this kind of prediction. After 5 minutes, what is the share price of my IBM? Suppose I invested into IBM. For every 5 minutes, what IBM is going to happen? What is going to happen for the IBM share value? Suppose in the next 5 minutes it is going to be down, immediately I will sell out. In the next 5 minutes, if it is going to up, immediately I will purchase one more share. Such kind of for every 5 minutes, what is going to happen? For every 5 minutes, what is going to happen? On the future of 5 minutes, within the future of 5 minutes, I want the prediction. So to perform such kind of things, this task comes under micro batching area. Tomorrow, what is going to happen for the IBM? That is batch. Okay, after 24 hours, what is going to happen for the IBM? That is batch. But in the next 5 minutes, what is going to happen for the IBM? That is micro batch. Exactly, Spark streaming area is this micro batch. Okay, all of you, please switch on your mics. Yeah, about this, please questions about our discussions. Yeah, Sweta has asked one question here, typed one question here. Can we fetch logs, tweets, chats, data directly using Kafka without using Flume? Why not, Sweta? Definitely we can fetch.
Okay, then what is the
Then
importance
what is the importance of the Flume, right?
Yes.
Yeah, because if there is a Flume, think that today Kafka came into picture. Already you implemented your big data applications some 3 years back. That means for the past 3 years you are capturing all the streams by the Flume, right?
Yes, yes.
Okay. Already your old application in the old streaming application into the Flume. Okay. But today Kafka came into picture. Immediately you cannot replace the Flume with the Kafka. Because if you immediately replace it, a lot of dependency is there, right?
Yes.
Yeah, that is a problem. That's why you integrate with you integrate that Flume with Kafka.
Yeah, got it, sir. Got it. Thank you.
Yeah, again, why to integrate Kafka? Directly Flume is writing into Hadoop, right?
Yes.
Flume is writing these tweets into Kafka. Sorry. Now, as per our previous architecture, Flume is directing these tweets into only let's talk about tweets, your social media tweets. These tweets are redirecting to Kafka. But Flume is directly able to write into Hadoop, right? Why
Yes.
Kafka here is, think that a small example, nowadays, suppose you are one bank user or one mobile user. Nowadays, each and every organization providing you one provision that you can raise complaint even from a social media.
Okay.
Suppose you got any problem, you can raise your complaint from social media. No need to call to the call center or service center, or no need to send even email. Directly you can tweet in social media, in their groups or in their pages. Got my point?
Yes, yes,
Whatever the
got it.
compliant tweet you have produced, this compliant is required to Hadoop system. At the same time, this compliant is required to Storm system, whether this compliant is really genuine or not, and a really valid customer or not, that is decided by the Storm immediately. And
Yes.
suppose if I redirect this message to the Kafka, Storm can use it. Their CRM application, customer, they maintain one customer relationship management application, right? They, the service, the CRM application can use this message. Storm can use this message. Even later, the Hadoop can use this message. Getting this point, Sweta?
Yes. Yes, sir. Yes.
Yeah.
I got the complete
Yeah.
picture.
Still any other questions, please? Jagan, doubt లేదా? మలయ, మురళి, పవన్, ప్రశాంత్, శ్రీనివాస్. శ్రీనివాస్, ఈరోజు మీరు మార్నింగ్ క్లాస్కి వచ్చారు మీరే కదా? శ్రీనివాస్?
హలో
ఎస్,
నేనేనండి.
యా, మీరే కదా క్లాస్కి వచ్చింది. యా, అంటే నేను మర్చిపోయాను మీ గురించి, అందుకే నేను లేట్గా పంపించాను లింక్ మీకు. ఓకే ఓకే ఓకే. యా, వినయ్, anybody has question, please? Now, okay, I think you understand clearly. Now, please switch on your mics. I will tell you the task. Okay, what Spark ecosystem is used? First, you tell me. My data is this one. This is airports data I'm taking. Airports and simply logistics example. Okay. This is port 1, port 2, port 3, port 4, port 5. This is like this. This is airport number 1. From this airport to different other stations, the flights are dispatching. This is one side. This is another thing. This is another thing. And this is another thing. See, this is like this forward arrow is indicating like dispatching. The incoming arrow, this is indicating arrivals. Now you tell me, there are 5 ports involving into here. Which airport is popular in dispatches, sir? Departures. Which airport is popular in departures? Come on, all of you, anybody?
First.
Yeah,
P1,
first.
sir. P1.
Now, yes. Which airport is popular in arrivals?
P5, sir.
P5. In this way, think that entire worldwide, hundreds of airports, let's consider. The top 3 departures ports, the top 3 arrival ports I want. What ecosystem you will use? What component you will use? This is my task. Data is this one. This is graphic representation. I am making this data structure. P1 to P2 there is a journey. P1 to P5 is also journey. P1 to P4. P1 to P3. Again P4 to P1. P4 to P5. On such way data is there. Only 2 columns. If you observe these 2 columns, data is like equivalent to structured only. What component you will use? This is my question. The top 3 departure airports, the top 3 arrival airports I want. Which airport is popular in airports? The top 3 airports I want. Come on, please recommend me. Even though it is wrong, please try.
Sir, Spark streaming, sir. Because we are calculating the top 3 and departure and top 3 of arrivals. So it's a micro.
ఎందుకు మైక్రో ఎందుకు అవుతుంది?
Because
మైక్రో
we are
బ్యాచింగ్ మీన్స్ వాట్?
considering
ఒక్కసారి ఆలోచించండి.
only
మైక్రో
departure
బ్యాచింగ్
and
అంటే ఒక్క నిమిషం వినండి.
okay.
ఇఫ్ ఇట్ ఈజ్ మైక్రో బ్యాచింగ్ నాకేం రిక్వైర్మెంట్ ఏంది? 2 నిమిషాలకి ఏమవుతుంది? 5 మినిట్స్కి ఏమవుతుంది? ఎవ్రీ 5 మినిట్స్ వాట్ ఈస్ హ్యాపెనింగ్? దిస్ ఈస్ వాట్ మై రిక్వైర్మెంట్. From airport Shamshabad to USA airport within 5 minutes the journey will happen? No, right? Already
Yeah.
I collected, suppose this is the data of the Indian Airlines. Think that Indian Airlines services are for all over the world. They have given me some 3 years data to me. Only Indian Airlines point of view, you tell me this one. That means this is completely purely batch process.
Yes, sir.
Based on the previous entire historical data, I am going to analyze this. Definitely it is not Spark streaming.
So we will be using the Hadoop.
Hive.
Okay, boss. What I am saying is, let's come out of the Hadoop. Already my storage system is Hadoop. This entire 3 years history data is stored in Hadoop only. For the processing, what I am using, Spark I am using.
Batch.
In the Spark purpose is batch only, batch processing only. MapReduce or Spark purpose is batch processing only. For the batch processing in the Spark, what component you will use? You will use Spark SQL or you will use Spark GraphX or mlib. What data you will use?
SQL.
SQL. Yeah.
Why SQL?
It gives quick result.
Because data is structured, that's why you are saying SQL.
Yeah.
Yes. But I don't recommend SQL in this case. Observe this record structures. P1 to P2, P1 to P4, again P4 to P5. There is a connections between records or not?
Okay.
Again P5 to P1, there is a connection between records or not? One record to another record, direct or indirect link is there or not?
Yes.
Getting my point?
Yes, yes.
That means this kind of connections between the records is called what? Graph data.
Graph data.
If it is graph data, what Spark component you will use? Spark GraphX. SQL cannot deal such kind of situations. Got my question?
Yeah.
Suppose Facebook users, Ravi is user, Rani is friend. Rani is user, Giri is friend. Again Giri is user, Vani is friend. Vani is user, Venu is friend. Observe this data. Record to record connection is there or not? Is there connection between Ravi and Giri? In terms of Rani, there is an indirect connection, right?
Yes, yes. Yes.
Rani is friend of Ravi. Giri is friend of friend, right?
Friend of, yes.
That means record to record different connections are there or not? Generally, we have connections between one table to another table in terms of primary key and foreign key. But here within a single table, the connections between records are established. Such kind of data is called graph data. To process such kind of typical graphs, the Spark GraphX, we need to use different graph algorithms. All these predefined graph algorithms are available in GraphX. Getting my point?
Yes, sir.
Sir, if we go with a Hive, like, can we group the data based on
Yeah,
each
you can
department?
group it. You can group it. Observe this. Like, may I know the name who asked this question? Who speak recently? Yes, Shweta. Just
Shweta.
observe. P12, P3, P22, P4, P12, P5, P62, P1, P72, P1 again, P32, P1 again. Now just group it. Group it by the first field. What will happen? How many groups you will have? Only 2 groups you will get. What about these P1s? You are missing or not?
Okay.
శ్వేత అర్థమైందా?
Yes, sir. అర్థమైంది.
ఇప్పుడు నేను గ్రూప్ చేస్తే ఇప్పుడు ఆల్ P1s అంతా కూడా లెఫ్ట్ సైడ్ ఉంటే ఓకే. బట్ వాట్ అబౌట్ P6, P7, P3? There is no grouping, right?
Yes, yes,
That means
sir.
those 3 records are missing, right?
Yeah.
Yeah, that is the problem here. Okay?
Okay.
That too, this is not like అంటే observe the relationship between P6 and P3. Think that this is P2. What is the relationship between P6 and P2? Think that for some time this is Facebook user, this is Facebook friend, not ports. There is a connection between P1 to P2, P1 to P6, there is a relation.
P6.
But what is the relationship between P2 to P6? P2 is friend of friend, right? Getting
Yes,
my point?
yes, sir. Yes,
Yes, yes, yes.
yes.
Is a friend of friend. Like this, I want a third level friend. This is first level friend. Sorry, second level friend. I want third level friends. I want fourth level friends. Okay, now observe this. A to B, B to C, C to D. Who is C for A?
Second level.
Second
Second
level
level.
friend. Who is D for A? Third
Third.
level. Who is E for A? Fourth level. I
Fourth
want
level.
to list out all the fourth level friends. Come on, try to write a SQL query for this. Even though we are experts in SQL, we cannot able to write it. Because to process such kind of data, not simple SQL statements are enough. You need to apply different graph algorithms. All these graph algorithms are in Spark GraphX. Nowadays, how different people are connected each other. Similarly, lot of data objects are connected each other. Lot of records are connected each other within a single entity. So nowadays there is great importance for this graphing kind of data. Regularly, what we see the graph algorithm example is Google page ranking. For this, they used to apply the algorithm called Pregel algorithm. The algorithm name is Pregel. See, a small example. I am giving you one. Suppose this is a search box. I am giving you the word called Hadoop, or else the word called big data. Now, what it will show me? Come on.
So many pages related to big data.
Huh? All pages related to big data, it will show me, right?
Yeah.
All pages which are related
Including
with
most.
big data, it will show me. Okay. Now, it is showing me some 1,000 or 10,000 pages. But who will be there in the top first page?
Number of visits and the link who has visited more number of times will be coming in the top.
Not only that one, completely based on ranking model. How this rank is applied is, for the rank, number of visits is one thing. Suppose I am entering into a lot of pages, directly we will not find. First we will enter into page 1. We don't like it. After that, from page 1 you will find some other link. After that you are going into page 2. And from page 2 you are coming into page 100 by seeing some link. After that again you are coming back to page 1. Again page 1 to page 3 you are going. Page 3 to page 7 you are going. Again from page 7 you are coming back to page 1. Now again in all these things, which page is more popular?
P1.
P1 is more popular, right? It does not based on number of clicks on that one, number of like traffic directions, number of traffic diversions. Based on this, the ranking is calculated. Now this is not a Google pages. Try to apply this for Facebook user. Try to apply this for airports or bus stations or railway stations or telephone numbers. Phone number 1 to phone number 2, phone number 2 to phone number 3, again phone number 3 to phone number 1. That means which number is more traffic, creating more traffic here? The P1, P1, the first phone number
P1.
is creating more traffic. So rank number 1 goes to P1. Based on that, Google will first display is P1. And not only Google is using for their web pages, airports can use for their ports, and that means for their air stations. And Facebook can use for user and friend connections. In this way, in so many areas, this graph can be applied. For this, they use Pregel algorithm. This Pregel kind of a complex algorithm is predefinedly available in Spark GraphX. All algorithms related with graph data processing are available. Okay, we need not to write any complex code for that. Already that library is there. Just how to use that library, if you know, that is enough. Getting the point?
Yes, sir.
Yeah. And one more thing I am giving you. Suppose I am taking users. User 1, he has watched movie 1, movie 2, movie 3 and movie 100. And user 2, he has watched movie 1, movie 2, movie 7 and movie 100. User 3, he has watched movie 1, movie 2, movie 3, movie 7 and movie 4. And user 1 has a rated 4 rating for the movie 1, 3 rating for the movie 2, 1 rating for movie 3. That means he doesn't like. Think that less than 3 he doesn't like, greater than 3 rating he liked it. Okay, and here 1.2 rating. And movie user 2 for the movie 1, he has given 4.7 rating, and movie 2 3.3 rating. For movie 7 0 rating. For movie 100 he has given 1.1 rating. Again here rating 4 3.7 1.2 and 5 rating, and movie 4 0.3 rating, like this. Now I want to build recommendation system. See, let's talk about user 1 and user 2. User 1 and user 2. User 1 has watched how many movies? All of you please. User 1 has watched how many movies?
4.
3 movies.
4 movies. Okay. User 2.
4.
4 movies. How many common movies are there? Between user 1 and user 2, how many common movies are there?
2 common.
Only 3 movies. Movie 1, movie 2, movie 100, right? Let's talk about only user 1 and user 2. User 1, user 2. Movie 1, movie 2, movie 3. Or reverse this one. Movie 1, movie 2, movie 100. I am considering only 2 users. What is that movie? What is the ranking rating the user 1 has given? 4, 3, 1.2. 4, 3, 1.2.
1.
What about user 2? 4.7, 3.3, 1.1. 4.7, 3.3, 1.7. Okay, think that rating below 2.5, user did not like it. Greater than 3, greater than 2.5, he liked it very much. Now, user 1 liked what movies, sir, here? User 1 liked what movies? Movie 1 and movie 2, right?
1 and 2.
User 2 liked what movies? Same movies, right?
Yes.
Both have watched three common movies. Think that this is not 3, this is 300. Out of 300, think that 270 movies mostly liked by both the people, right? That means user 1 taste, user 2 taste similar or not?
Yes.
All of you, please. This is very important. Such kind of things you need to explain as Spark projects. User 1 taste and user 2 taste are similar or not?
Yes.
Okay, that means their likes or their tastes or their preferences are same. But observe this. What is the other movies? Movie 3 and one more movie, movie 7. Movie 7 is watched by user 2. Movie 3 is watched by user 1. That means user 2 did not see movie 3 yet. User 1 did not see movie 7 yet. But user 1, user 2 likes and tastes and preferences are same. That means whatever he is liking, he is also liking. Whatever he is disliking, he is also disliking. This kind of basic understanding we can do. That means movie 3, think that for the movie 3 and also like think that movie 3 did not see, but think that he has given 4 rating. That means movie 3 is liked by user 1 or not?
Yes.
Movie 3 is liked, if the rating is 4, movie 3 is liked by user 1 or not? That is liked by user 1. But this movie did not see by, this is not seen by this user 2. That's why this movie 3 is a recommendation to user 2. Similarly, if movie 7, he has given 4.2 rating. This movie 7 is a recommendation to user 1. Understand, sir? Based on the similarity between the users, the recommendation systems are built. Such kind of recommendation system I want to build. Today I signed up into some movie site. I purchased different movies. Tomorrow again I log in. I need some recommendations. You may like this movie, like that. What Spark component you will use in this case?
Spark MLib.
Yes, very good. Spark MLib. This kind of things comes under MLib, machine learning. Understanding the point, sir? So in this way, it depends on the task. We have different components here in the Hadoop. That means in the Spark. In order to implement all these things in MapReducer, really it is very tough. But Spark has a powerful library, that too very speeder, in-memory computing, DAG model, heavy distributed, highly effective fault tolerance model. All these things are with Spark. Got the things? Okay. Come back to the things. All of you clear about this?
Yes, sir.
Yes, sir.
Yeah. Again, tomorrow we will meet, and tomorrow this is like a high level architectural diagram of the Spark. What are the components? Each component is doing what? This is the discussion. Tomorrow we enter into Spark core architecture. Okay. So what exactly the RDD? How RDD is distributed into your Hadoop cluster? Okay. When you run some process, how the execution will happen? This kind of architectural design we will see tomorrow onwards. Okay, it may take another 2 or 3 sessions for this core architecture. Then once this architecture part completed, we enter into Scala coding. Right? Okay, I'm stopping recording.